Hello, everyone. Welcome to the Advanced Manufacturing Technologies for Welded Structures course. Today, we will study the important topic of boom assembly. I'm your lecturer, Xiao Yong. Boom assembly is a crucial part of mechanical manufacturing, and it plays an important role in understanding the production process and quality control of mechanical products. As a key component of an excavator, the quality of boom assembly directly affects the machine's performance and service life. There are many details to pay attention to during boom assembly, from preliminary inspections to the actual assembly process, and to the specific process requirements of key components. Each step is vital. Let's begin with pre-assembly inspection, the foundation of the entire process. Just like building a house starts with laying a solid foundation, only when the base is stable can the structure stand firm. Inspection focuses on two aspects: component inspection and fixture or tooling inspection. Component inspection includes checking appearance dimensions, surface quality, and contaminants. Dimensional inspection must strictly follow design requirements to ensure that each part is accurate. Even a tiny deviation can cause major problems during assembly, leading to poor fits and performance. Surface quality inspection must not be taken lightly. We need to carefully check whether the surface of each component has defects such as burrs, flanging, or deformation. These defects not only hinder smooth assembly but may also cause stress concentration during the use of the boom, thereby reducing its strength. Contaminant checks are equally important. Oil or debris on part surfaces can negatively impact welding quality and aesthetics, so cleanliness is a must. When inspecting components, we must adhere to strict standards and requirements, conducting a thorough and detailed examination of each part, leaving no potential quality-affecting detail unchecked. Tooling inspection is also essential. We need to check the types and quantities of the assembly fixtures used, ensuring that they are complete and in good condition. Different assembly stages require different fixtures. If any type is missing, the corresponding assembly operation cannot be completed. If the fixtures are damaged, the accuracy and quality of the assembly cannot be guaranteed. For example, without proper positioning fixtures, part alignment may shift, reducing the overall precision of the boom. Now let's move on to the key part, assembly procedure. Boom assembly is a sequential process that must follow a specific order to ensure quality and precision. The first step is installing the upper support plate. As a key structural component of the boom, its position and precision directly influence the installation of subsequent parts. During this step, ensure the support plate is accurately positioned and flush with the connecting surfaces of other components. The second step is the assembly of the main plate, which serves as the core of the boom structure. The quality of this assembly critically affects the boom's overall strength and stability. Special attention must be paid to its precise fit with adjacent components. The third step involves assembling the front, middle, and rear brackets. It is essential to ensure the relative positions of these supports to the main plate are accurate. Prior to final welding, internal weld seams between each bracket and the main plate must be completed. The quality of these welds is vital to the boom's strength. Welds must be full and defect-free to ensure durability and structural integrity. The fourth step is the installation of the boom ribs, which enhance structural rigidity. During this process, ensure the ribs are precisely aligned. Strict control of welding deformation is necessary, and weld quality and surface finish must be carefully maintained. The fifth step includes assembling the rear end plate and rear support plate. This step also requires precise alignment and secure welding to ensure a strong, stable structure that meets design and strength standards. The sixth step involves assembling the lower wing plate and its reinforcement. This process must be executed with precision to ensure flat, seamless joints and top-quality welds that guarantee the overall integrity and load-bearing capacity of the boom. The final assembly steps include installing the left and right nut blocks, as well as the left and right reinforcement plates. These components must also be installed in strict accordance with process specifications to ensure overall performance. In addition to following the correct assembly sequence, it is crucial to fully understand and implement the technical requirements for key components. For the support plates, precision in dimensions, even gaps, and firm connections are mandatory. In practical operations, the plate surface must tightly contact the positioning seat. The internal opening should be controlled between 61 to 62 millimeters, and clamping devices must be secured with the front and rear edges kept parallel. All welding must strictly follow relevant standards to ensure a stable and durable structure. When assembling the main plate with the front, middle, and rear brackets, precise alignment and gap control are essential. For example, the brackets should be symmetrically positioned on the left and right sides. The inner spacing of the main plate should be 118 millimeters, and the telescopic rod must fit accurately into the grease-fitting hole on the rear support. This ensures alignment accuracy and structural integrity. For internal cavity welds, the weld quality between the front, middle, and rear brackets and the main plate must be strictly controlled. The welds must be full and free of defects, as this directly affects the strength and durability of the welded joints. For rib installation and welding, precise alignment is essential, and weld deformation must be strictly controlled. Weld quality and appearance should be smooth to enhance overall strength and stability. Assembly of the rear bent plate and rear support plate requires careful detail management. Accurate alignment and strong welding are necessary to ensure a stable structure that meets design and strength specifications. When assembling the lower wing plate and its reinforcement, the connection areas must be flat and seamless. The weld quality must meet high standards to ensure the structure's integrity and load-bearing capacity. For instance, the gap between the lower wing plate edge and the main plate should be 12 millimeters. The reinforcement plates should be symmetrically aligned with the upper wing plate edges. The tack welds for the support plates should have a leg size of 4 to 5 millimeters, placed at least 30 millimeters from the end, with 2 welds per connection point. When assembling the main plate and lug plates, templates should be used for precise alignment. The flatness, gaps, and weld quality at the lap joints must all meet strength and functional requirements. Classmates, boom assembly is a meticulous and rigorous process. Each step plays a critical role in determining the final quality of the product. I hope today's lesson helps you master the key points of boom assembly. In your future studies and practical work, always operate strictly according to process standards and strive to contribute to the production of high-quality mechanical products. This lesson is concluded. Thank you for listening.